All right, good morning, class. All right, so I am going to, today we're gonna do our warm-up. We're gonna go over Unit 4 notes, Section 4.2, 4.3. My learning target is I can identify the depreciation amount and rate of a car using straight line depreciation and expense function. So we'll go over that, the notes, and we'll have a small assessment at the end. So I am going to model the warm-up. Okay. All right, so I'm gonna read it. It says, decides total cost to attend college, including all fees, books, and room and board is $28,450. Decide receives $5,500, and an instant scholarship from the college, and has a $4,175 in scholarships. What is Decide's net price to attend college? Okay, so first I'm going to model. I am going to underline the important variables in this problem. $28,450. The scholarship, one of them is $5,550, and the other scholarship is $4,175 in scholarships. So the question says again, what is Decide's net price to attend? So I know, looking at this is the total cost of the tuition. And my scholarships was just free money, which we learned in Unit 3 when we did a college project. So I'm going to take my $28,000 here. However, I got two scholarships. So I'm gonna go over here and add the two scholarships together, because since scholarships is free money, I know I need to subtract. So I'm just thinking out loud. I got my $5,500 and I got my $4,175. So I'm gonna add these together to tell me my scholarship price. Okay. So in scholarships, she received $9,675. This is what I'm going to subtract. This is what I'm going to subtract from the price of the tuition to make the price go down. So it's $9,675. Okay. So I'm going to go and calculate that and tell me what will be the cost. So I go to my decimal calculator. And I'm gonna put in 28,450 minus 9,675. That gives me $18,775 for a net price. So the net price for her to attend is $18,775. That's the price for her net price to attend college, and that's how you find the net price. All you're doing is subtracting scholarships. If it was deductions, I would be subtracting the deductions. Okay. All right. Any questions on that? All right, go ahead and take out your Unit 4 notes for me. Unit 4 notes, we're on page 6. On page 6, we're going to look at example 4. Alright, so I'm gonna model example number 4. We're talking about linear expense and straight line depreciation. Let me make that a little bit bigger. Alright, so number 4 says the straight line depreciation equation for a luxury car is y equals negative 3,400x plus $85,000. Okay, so straight line depreciation formula, y equals mx plus b. This is the formula. Okay, so it says, what is the original price of the car? So I know, using my straight line depreciation, I know M is standing for the original price. I know my M stands for depreciation amount. And I know my X means time in years. So that's why I go back and look at the formula first. Now, what is the original price of the car? So I know using this formula, looking at this, just thinking, I know this right here is the original price of the car according to my formula. So that's gonna answer question number 1. Question number 1 will be 85,000. According to the formula, and according to this question, what is the original price of the car, which is $85,000? Second question, how much value does the car lose per year? Okay. So, looking at this, and I know my depreciation formula, this is my depreciation amount. This is how much it's losing every year. Negative $3,400. Now, how many years will it take for my car to totally depreciate? That's what I need to find out. Okay. So, I don't know my years. So I got negative 3,400 x plus $85,000. So I'm gonna basically divide. So I'm turn this over here. I'll make this negative 85,000. So if I was to divide, I'm gonna divide 85,000 by 3,400, maybe 3,400. So I'm gonna go to my calculator. And Desmos. Give me 25. X is gonna be 25 for my time. Oops. So this car would totally depreciate in 25 years. Years. It will totally depreciate in 25 years. So the answer for C is 25 years. work example number 5 together, okay?
Mhm.
Alright, so question says the straight line depreciation equation for a car is y equals negative 2,750x plus 22,500. So here it says, what is the car worth after 5 years? So we're using depreciation, straight line depreciation formula. So, I got my time, right? And we're gonna go back here.
You divide it by.
We're gonna go back to the formula. Right here. So now, it's already written, all I need to do is substitute my 5 years, because that means time, right? So I got my 5 years. So I got y equals negative 2,750 times, substituting that x for 5, because it says 5 years, plus 22,500. Go ahead and plug that into Desmos. Plug that into Desmos just like this. Write that into Desmos just like that. Y equals negative 2,750 times 5 plus 2,250. Everybody should be plugging in. Okay, go ahead and plug in.
Formula into it. Missed it.
Once again, the formula's on the board. This is what you're plugging in. All you're doing is writing it just like that. You're writing just what I just wrote, right here.
Oh, no, this one.
Yeah, this is what you're calculating. I want everybody to calculate it and tell me what you get.
36, 250.
Hmm?
36, 250.
Hmm.
I got 8,750.
Yo,
That's not it.
what you get, Mariana?
6,750.
Alright. What you get, Kayla? Take your earbuds out there.
807.
So the car be worth, according to this, the answer should be 8,750. Take it up. That is correct. Okay. Now, what is the car worth after 90 months? First, we gotta take those, because we're doing time in what? Years, right? So we got months, that means we need to turn it into what? In order to do that, how will we turn it into years? Jose? Matthew? How y'all turn it into years? Not multiply. Divided by 12, right? So we got 90 months divided by 12. What is that, Jose? Matthew, what is that?
7.5.
7.5. So that gives us our time, right? Okay.
7.5 years.
So now, we got what we need to plug in. First it was 5 years, now they're asking for 90 months, which is 7.5. I want y'all to go ahead and write that out. Tell me how I should write this out. The second one. Similar to the first one.
Y equals, negative 2750, the quotation marks, and then 7.5 plus the 22,500.
I want everybody to put this in their Desmos. I'm gonna come around and take a look at your answer. Put this in Desmos and tell me what you get. You don't have to call it out, but I'm gonna come around and look.
it, man.
Alright, so judging from this, your answer should be. So I got 1,000.
Yeah, 1,875.
That is the correct answer. Okay. Good job. Seems pretty easy. Alright. Let's go on. We got an expense function formula to learn. Talking about monthly payment, down payment. So turn to page 7. Turn to page 7 in your notes. Let's look at the expense formula. Okay. What's that? Alright, come on. Okay, so comprised of two major expenses of a car. So two major expenses of a car is your monthly payment. Just like your car note. Monthly payment and your down payment.
Okay, Joanne.
Monthly payment and down payment. So, it's still gonna be y equals mx plus b. M stands for our monthly payment. M stands for our monthly payment. B. B stands for our down payment. And X, only difference is it's gonna be time in years. I'm sorry, time in months, sorry. Time in months instead of years. And this is for the expense formula. So on this one, what does M represent on this one?
Monthly payment.
X,
Time and months.
B,
Down payment.
okay, yeah. That's the only difference with the expense function. So let's look at an example on this one. Let's look at example 6. Alright, so example 6 says Celine bought a new car for $33,600. She made a $4,000 down payment and pays $560 each month for 5 years to pay off her loan. She knows from her research that the make and model of the car she purchased straight line depreciates to 0 over 10 years. Okay? So what should I underline in this problem?
4,000.
What else? 33,600. What else?
506.
Okay.
10 years.
Okay. What else?
Straight line.
Okay. What else? 5 years. Okay. So the first question says create a straight line depreciation function. That's what we're gonna do. Alright, so we got years, but we gotta take it down to months, right? So in order to take it to months, we got 10 years. We're gonna multiply that times 12. 10 times 12 is what? 120. So I got 120 months. Okay. So $33,600. Got our months, 120, 0. I want y'all to put that in decimals and tell me what you get. Put that in decimals and tell me what you get. Matthew, Jose, put that in decimals and tell me what you get. And plug it in just like that. Don't worry about the M, just plug it in the numbers.
I thought we was doing this with this.
I got
Negative 280. Negative 280 is what? What is that? What's this called? That would be what? Depreciation, right? Because it's negative, right? So, it says write the straight line depreciation equation. We got the number to write it now, right? So, y equals, what goes here first? What is our M? M is gonna be the depreciation amount, especially with straight line. It's always negative. Negative 280 x plus the 33,600. That is our equation. Now, it says it's an expense function. I want y'all to tell me how to write an expense function according to the formula that we just did. So I got y equals what? What do I put next? What does M stand for? M. The monthly payment. What's the monthly payment in here? 560. So it'd be 560 x plus, what does our B represent? The down payment. What's the down payment in the problem? What's the down payment in the problem, Mariana? How much is the down payment in the problem? $4,000. 4,000. Now, that's the expense function. So now it's asking, in how many months will Celine's expenses and car value be the same? Did this shut off? Alright, so I want y'all to go ahead and plug in the expense function and the depreciation function into decimals. Go ahead and start plugging it in first.
You still,
Uh-huh.
can I go to the bathroom?
Yeah.
I mean, can I go to the bathroom?
Yeah. Let's work this problem. Let's finish this last question and I'll let you go. Okay. I want y'all to plug it in and tell me what you get. But first plug it in, but you're gonna need something extra in decimals. Wait till my screen pop up. Alright, let's go ahead and plug it in. So we got y. Y equals 560X plus 4,000. I want y'all to stop right there. Okay. Everybody done plugged in both? So you see this little wrench right here on the side? There's a wrench on the side of your decimals. I want you to click that for me. Okay. So now the y-axis over here, right here, that needs to be over the highest amount, which is 33,600. So here I'm gonna just put 35,000. I want y'all to put about 35,000. Put 35,000 just right there. Okay. So now let's go back to the graph. Now we gotta find out where these points meet. So I'm gonna bring mine in. Y'all can bring it in. We're gonna find out where the points meet. And that will be our answer. Yours should look like that. My points shows 35.23. You're gonna find out where they meet, where they intersect. You have the same thing? You got it? Okay. So, at how many months, answering that question, at how many months it's gonna be 35.2 months for that question. 35.2 months. C. 35.2 months. 35.2 months. All right. All right, so I want y'all to go ahead and work on example number 7. I'm gonna have to show you how to do it. Same thing, it's just you're finding the monthly payment. Kaylee, you can go to the bathroom. Just leave your phone near this. Thank you. All right, go ahead and work it, go example 7. Thank you. back together on this question that I had y'all work individually? Let's take a look. Question says, when you purchased a new car for $54,000, she determined that its straight line depreciates to zero over 10 years, and when she purchased the car, she made an $8,000 down payment and financed the rest with a 4-year loan at 4.875%. All right, let me get somebody to come and underline the important variables in this problem. Matthew, give me the variables in this problem. You can use this one. Good job. Tajay, give me the answer for, give me the answer for A. And I want you to write out the variables. Write out the P, the R, and the T, and then give us the answer. Okay? Mariana, I want you to do B, part of B. I want you to give us the expense function. Do y'all agree with Tajay? $1,556.74? Matthew, you agree?
Mm-hmm.
What you get, Matthew? That's the answer. Create a depreciation expense function. Expense function. Why? Tell me what I should write, Mariana. For our expense function. No, it's the monthly payment. Y equals, you got the second part right, but it'll be the monthly payment, which is 74 plus 8,000. So good on that part, which is just the monthly payment. Depreciation would be negative 450 x plus 54,000. And when you put those two together, C would be 30. When you do the points, y'all can check it, 30.5 months with the value. And then when you do those same points, the same thing we did in Desmos, it'd be 40,261.73. Alright, so I know we got a few minutes left. So, our learning target today of what we learned is I can identify the depreciation amount and rate of a car using straight line depreciation and expense function. We worked on some problems, did some practice. I want you guys to continue to practice. I have a Go Formative 4.1 and 4.2 that I want you guys to complete. We'll continue on. The next time we meet, we'll be working on page 8, and then we'll go on exponential depreciation. So we're gonna continue on with unit 4. Also, there's a unit 2 remediation. If you feel like you wanna score higher on the unit 2 test, I would advise you to take that, which is on my e-class page. And I think that's it for today. Y'all did a good job. I appreciate it. Any questions?
Is the unit 2, is it open, like I don't gotta email you?
You don't have to, email, but email me when you're done.
Okay.
It's on my e-class page.
I'm gonna email you about when I'm done with the Go Formative and,
Okay.
For the Go Formative, they will only do 2.
I'm sorry?
For the Go Formative, they will only do 2 questions, or we do all of them?
You're doing the whole Go formative.
Oh.
Yeah, you're doing the whole thing. Okay? Uh-huh. What's your question? Okay. That's similar how we did here. What you did here, and you got the depreciation, so it's similar to that. All right, y'all, have a good one.